Hi everyone, today we're going to continue our analysis on throttle that we talked about in homework 8, problem number 4. Today we're going to continue with part B. So same thing, we're going to highlight important information. So this time on a normal day, the required pressure at the outlet of the throttle is 16 megapascal, and what's the phase and temperature of water at this condition. So just to help you visualize this problem a little bit, I'm going to draw a throttle here. So we know from part A that the inlet pressure, P1, is 18 megapascal, and the outlet pressure from part B, we know is 16 megapascal, and our goal is to find the phase and temperature. So if you recall that the relationship now the relationship necessary for throttle, there's a very important piece of information. H2 is equal to H1. And if you don't remember this equation, that's fine, because we can always derive it from our steady flow energy equation. So delta M times delta H plus delta KE plus delta PE is equal to Q dot minus W dot. And from the previous video that we made some assumptions there. We said it's steady flow, Q dot, W dot, delta KE and delta PE. So these are all zeros. So I love that, because then we can simplify our equations. So we're left with now just delta M, delta H is equal to 0. And this delta M can be also eliminated, because if you just divide that over, it's gone. So now we only have delta H, which is H2 minus H1 is 0. So H2 is equal to H1. The reason why we're finding this H2 and H1 value is because if we can know the H2 value, then we can compare that with the H at a vapor phase, and then we can determine the phase of this condition. So if this H2 is bigger than H at the vapor phase, then it is a superheated vapor. If it's the same as Hg, then that is vapor. If it's smaller than that, then it could be a mixture or a liquid. So let's try to find out what H2 is. We can't directly find H2, but we can find that from H1, because we know at state 1, P1 is 18 megapascal, and T1 is 640K. And if you go to table D.3T, you can find that H1 is 2652.8 kilojoule per kg. And this is also H2, because H1 is equal to H2. So now if we compare this H2 with Hg at P equals to 16 megapascal, our H2 is actually bigger than Hg. So this tells us it is a superheated vapor. Okay? So now we're going to move on for solving the temperature. For this part, we actually need to interpolate, because if you just directly go to table D.3S, which is for P equals to 16 megapascal, you're not going to find the value that you want, because it's just happened to be somewhere in between the value that you see. So that's where we need interpolate. So if you don't remember how to interpolate, I'm going to just do a quick review here. If you remember how to do that, just fast forward and then you will see the answer directly. So I'm going to draw x, y axes here. So x and y. So this is going to be T, and this is going to be H. So we're going to use the H value that we have and the T value that we have to find out the T that we want. So if this doesn't really tell you anything, I'm going to draw the first two lines for table D.3s. So the first part, so let's do, this is T and this is H, okay? And we know that the first T, so I'm just going to look at the first two lines because our H2 value is sitting right in between these two values. So we have 620.5 and 640. And for H value, we have 25,080.8 and 2767.2. So if you notice that our H2, where is H2? Yeah, so our H2 value is here, okay? So this value is right in between the 2580 and 2767. So that's why we need to interpolate. So the first point, let's say this is point A and this is point B. So point A, we have 620.5 and 2580.8. So that's the first point here. And the second point is 640 and I don't have enough space, but I'm just going to write it here. 2767.2. So that's the second point. And our goal is to find, because let me use a different color here. So the value that we want is this H2, which is 2652.8. So this value is here, and we just want to find this temperature, T2, right here. Okay, so you can use the slope to find out what this value is. Okay, so the slope is this over this. So that will just be, let me change the color. So this is just going to be 2767 minus 2580.8 over 640 minus 620.5. So this is the slope for this highlighted green. And this is also equal to this over this. So that is 2652.8 minus 2580.8. This over T2, we don't know, minus 620.5. And if you solve this equation here, you can find that T2 is equal to 628.03 Kelvin. Okay? So hopefully this will help you just to refresh your memory on interpolation a little bit. And also, please let me know if you have any questions in general or any specific point on this one. Thank you.